Are we good to start? I'm sharing my screen. Let me know once it's up. You able to see my screen?
Yes, sir.
Okay. Now, what is the solution?
So for the this purpose, I
Mm-hmm.
think more bothered about the, as you mentioned, similarity. Uh, so if we can cluster those similar at the data based on some attribute values which are similar, then that may solve the purpose.
Okay. So how do you do that now? Okay, agreed. It's a similarity problem. But how do you do that now? What all data you think we would have? Or that is the question what you're asking, right? So I'll tell you what all data we might or we might not have, right? In some cases, it might be null. Name. So basically, name will have first name, last name, mobile number, and then we have what you call it as address, and then we have date of birth, and then we will have first name, last name, mobile number, address, date of birth. That is pretty much right. Correct.
Yep.
Okay, so this is the data what I have. And again, maybe for e-commerce, I'll have all of this mandatory for this e-commerce online. Maybe
Email.
for your email address, sorry, correct. That's what. Huh. These are the data set what I have. And maybe some information might be missing for this, some information might be missing for this, some information might be missing for this. Right? Maybe e-commerce, yes, you ensure that while you're logging in, you give all the information. So that would be there. Maybe date of birth won't be there, whatever, right? But these informations in some or the other form, we have it for some of these, or maybe all of it. We don't know. This is the data what I have. Now, how do you do similarity matching? Yes. How do you do similarity matching?
Number we can do the similarity matching because that is one feature which they have to capture from wherever they
Good,
buy.
good. So everybody, if you think again, this is not a technical problem, it's a logical problem, right? So if you think from a layman, this is what everybody would have it most of the time, mandatorily, is what our assumption is. Right? Maybe for offline stores, you might end up giving it or not, or you might end up giving a fake number. You never know, right? But still, this is what our first bet. So what you would do, you would match on this against another. So this is database one. This is sorry, what is happening? So this is database one. This is database two. This is database three. I have three. This is for ecom. This is for brick and mortar store. This is for distributors. Now I'll match all of this phone number, and wherever the phone number is matching, I'll say it as, oh, these are the match, and I'll generate a new customer ID for it, common customer ID. Correct? Noor, that is what was your approach, right?
Yes, sir.
Okay. Now, what are the problems with this approach? Like I said, one problem is maybe you might have given a wrong phone number just to ensure you're not closing your, not disclosing your identity. Or maybe you might not shown interest, you might have not shown interest in showing, telling your phone number, maybe for the offline stores or for the distributors. Which means that maybe you'll end up matching some of the customers. But still there are a lot. who are unmatched. That's wherein you try to do n cross n. You try to match mobile number, last name, first name, address, date of birth, and email. Correct? Yes.
Yep.
Okay. So that's wherein you don't have to worry about applying similarity on each of this column and then doing it deterministically. So we have a package who can help you do this. Record linkage, RL. Record linkage. So Santosh, over to you. Please share your screen. Let us deep dive into the solution.
Sure, sir. Same notebook. Shall I continue, sir?
Yes. So now, no, no, not here. This is done. Scroll down. Oh, you closed it, is it? Scroll down. No, no.
Similarity. This.
Up. Yes, correct. No, 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 not this. Scroll down. Scroll up, scroll up. It should be immediately after your sentiment analysis.
Okay.
Up. Above this, yes, above this. Correct. So now let's try to solve this. So scroll up. Let's start from scratch. Yes. Scroll up, scroll up.
Oh, okay.
Okay. So now here we'll install record linkage, and within record linkage library there is a data set they are giving us to play around. Okay. So now what is the error you are getting while you're downloading this?
Module have no attribute block index.
Oh, so it has changed. So see what is that? Uh, Instead of block index. Yes. So here linking two records, linking two data sets. No, no, no. Go there. Link two data sets. Make record pairs. Make record pairs or linking two data sets.
Here it is, sir.
No, no, no. No, no, no. Go back to the document. I'll tell you. Go back to the document. Yes. So yes. So here, if you look at it, link two data sets. There is a heading. First steps. Yes. No, no, no. Link to data set. Click on that. Yes. Link to data
Okay.
set. Yes.
Okay.
Correct. Right. So now here, if you look at it, they have loaded this data. Right? I'm using the same data set even in the notebook, right? So now this is how the data looks like. If you look at it, scroll up for given name, surname, street number, address one, address two, uh, what it is, suburb, I don't know what it is, pin code, state, date of birth. This is all the details we have. Now, how do you ensure? Then there is a similar data set collected from some other store. Now you want to do a record linkage. How do you do it? Oh, it's not block index, it's just index now. So you just index on from both the data set, you DFA, DFB, just to index there, yeah.
But sir, we have not taken DF B. So
Yeah,
here,
scroll down. No, no, scroll down. You should
okay,
have it. Go back to notebook, scroll down, scroll down.
okay. So DF we have here. Here it is. There.
Right?
Yeah.
So the whole point here is scroll down. Oh, here again you'll have to run through the notebook. Again, go to your document. That document, as in, I think, is good to explain you. Okay, so now here you read both the data sets. So you have DFA, data frame A, data frame B. Now scroll down. Now you want to do the record linkage. So first you need to block it. I mean, on to start with, okay, what is that you want to start with? Like Noor mentioned, a phone number. Here we are giving given name, right? This variable has to be the name of the column in DFA and DFAB. So in both the data set, you have the name which is common, and you believe that that has to be populated for most of the variables, right? So now it's an n cross n combination problem. Do you all get it? Do you all understand? Now there might be
Yes.
the case that the name might match with something else, and your phone number, contact number might not match. Right? One record from the left table might get linked to multiple records from the right table. So you should keep those mandatory columns with you, on top of which you will for sure say that yes, this is the one. Right? That's wherein you need to block this. Then scroll down, and then you try to compare the records where you put in all of those things, right? Given name, surname, and all of it. And that's wherein, if you look at it, right? Record one, REC underscore ID underscore one is your ID number from table one. REC underscore ID underscore two is your ID number from table two. Now here, if you look at it, right, the given name is matching, surname is not matching, date of birth is not matching, state is matching, address is not matching against these many records. Correct? Correct. So against 1070 ID, you have multiple IDs from the right table, which is getting matched because of the given name. And sometimes state is getting matched. Now, what do we do? Scroll down. Scroll down. All right. Now, here is a full code for you to achieve this. So iteratively, you block it against all the columns. And then you take probabilistic estimate. So now go back. Go back to the homepage of this. No, homepage of the same documentation. Go to home. Yes. So scroll down, record linkage. Then we have algorithms. Okay, which is comparing. And then you have classification. So these algorithms and classifications are built using those similarity functions. Click on algorithms. I just want to explain you how they are built. Right? So you don't have to write any code or anything of that sort, right? Where you just to record linkage dot compare dot exact, and you give all the details of the table and the column name. And it throws the output in terms of, oh, what it could be. Right? Again, like, there it's mentioned, right? It could be using cosine similarity, or it could be using Levenshtein distance, or any of those, Euclidean distance, or any of those, or Jarrow-Winkler method as well. So these are the distance metrics what it uses to match the string and then throw you the output. Right? Now you must be wondering, this is what I explained. Noor, you must be wondering, right? This is what I explained on the similarity matching. Why I need to use this record linkage library rather than directly having cosine similarity on top of each of this column.
Yeah.
Correct? So go to next. Classification. The third step. No, left. After comparing, there is classification. Yes. Click on it. So this will also help you probabilistically define, right? So it will tell you, oh, look, your name is matching by so much percentage or so much similarity. Your phone number is matching by so much probability. Now, what is the overall probability that these two records are same? These two customers are same. Does that make sense?
Yes, sir.
Right?
Yeah.
Similarity first, and then comes your classification. Because you do similarity, okay, by blocking phone number or by blocking name, I'm able to match this many. You deterministically match these two, and then you convert that as a classification problem, and then you run classification on top of it so that any new record comes in, you know to which customer ID you need to tag that to. Clear with the second problem, or this particular problem and solution? Now, right now in industry, this is not much widely used. 95 to 99% of the companies have solved this problem. Okay, so this is one example of how similarity, cosine similarity can be used on top of text to solve some of the problems. Is that clear? Any doubts or any questions on this? I want, so assign your assignment number 3. Hope you're clear about first and second assignment. I'm sure you might have taken note or followed of that already. The third assignment is build a record linkage solution end to end. You can refer either the notebook what I shared, or probably you can refer this documentation.
Same data set we can use, no, sir?
Yeah, use the same data set. It's hard to find publicly available data set.
Sure, sir.
Okay, so now the next one is, I'm sharing my screen, sorry. So if you actually look at it, this is what you could do easily, right? Okay, this is, I want the string match. I don't need an exact match. For date of birth, and maybe I think this is, I assume this is a phone number and this is a state. For this, I need an exact match. So you can mention the way you want the matches to be. So that's wherein the record linkage library has an edge over you using similarity or cosine similarity directly. Okay, and then on top of it, you can have probabilistic ECM classifier, where you just pass in the features and then you get the output on, okay, what all matching, what all is not matching. Right? Go through this, spend some time and complete with this with an output end to end. Maybe you can refer this. And now I think they have done much more progress from last 5 years. So that documentation is even better than this. Okay, so this is your third assignment. Now, moving on. The next problem. This is not effective and not being used much. Industry applications are rare. Now, let's say a news reporter is putting in some news. Okay, content. And he puts up a one-page content on a particular topic. Now, your task is to generate a headline for that particular news. Do you think there is a need for here to have a AI-based text summarization to generate this headline? Yes.
Yes. Yeah, because it may not be just one reporter and one report per day. So, and the headline should be catchy. So,
Okay, your points are valid, but my question to you is still the same. I agree, there are many reports, there are many such newses, and then it has to be catchy and all of it. I agree. But my question still is, do you need AI for it?
No.
If I can afford, yeah.
Okay, so someone said no there. Was it Noor or Purnima or Pravina?
Sir, no.
Okay, why no?
Because as Srihari told, it should be catchy, right? We don't need an AI to tell us which news is catchy, or like we can directly get to know. So I don't think AI is required for choosing a headline.
So basically, you have to generate a headline. Yes, correct. So now, anyone else who feels that there is a need for AI here? Anyone in the yes?
Actually, just to understand, the problem statement is we have lot many articles from which we need to concise. But you mentioned this new reports, news
Okay,
articles.
so
These are
let me,
different.
no, let me do this. So okay, this is how your news look like. Correct? Correct?
Yep.
So like this, you will have maybe 500 corners in the newspaper, or maybe more than that, 1,000. Okay. Now, this is written by someone. Do you agree?
Mhm.
Correct. Similarly, this is written by someone else. Correct. Whoever is, in charge of that. All those reporters do the job of writing this. Now, at the end, you need to you need to summarize this and write a good headline. Correct.
Yep.
True.
Correct,
So
for all of it, for all of
Yeah.
those such content. So now my question to you is this really a problem for us to generate headline?
yes, because editor may not be in a position to go through all the columns of all the news articles for a daily newspaper for a single day, or
Yeah.
at least editor can use those suggestions coming from AI to formulate his or her own headline.
Okay. Okay. Now my point is, the person who has written this from here till here, is he not in a better position to write a better headline?
Yes, but these are moderated contents. These are not the actual reportings or findings most of the time. So every news media will have some agenda or some affiliation with some ideology. So they fine tune their representations accordingly.
Okay. Or the person who is fine tuning this from here till here, don't you think he has a better context than AI to bring in a catchy headline?
That's true. That person will definitely have the domain knowledge, and he
Correct.
will also know what is it needed.
Correct. So my point here is, that's why I started this problem as this. People are trying to use it, but they don't find
Mhm.
it effective. Right. So exactly like Soumya mentioned, right? So maybe that our AI might generate 10 summaries from it. It has been the case that none of the 10 were useful or catchy or relevant for it. So they ended up writing their own.
Oh, is it?
Yes.
Is it the reality?
Yes, it's a reality. You will see it yourself when we implement now. Okay, but I hear recently, I think Google, uh, who watched Google latest key IO note?
One thing I want to add, I have seen the editors of some of big newspapers, how they work very closely, and they literally need to go through all the articles. The quality of the content submitted by most of the writers or the news agents is not up to the mark, except for few.
Mm-hmm.
So they don't know even the proper grammar, leave alone the heading or title. And
Mm-hmm.
that's the reality for most of the newspapers, especially the local one. which are in local languages. So I've seen editors marking, even correcting the grammatical mistakes.
Yeah, correct, correct. So all that is true, but what I'm trying to say is the summarization concept is not up to the mark what humans expect, right? So this is I said you right. This is in the latest, which happened a month ago, when Sundar was presenting his key IO note for the year. He did talk about summarization, which means that Google cracked it to a better state now than what it was few years back, or maybe even last year for that matter. So May 11th, 2022. Yes, exactly. 1 month ago, exactly 1 month ago. I did watch this. Right. That's how I understood on how they are tapping into Summarizer now. I think they are using transformers. Uh, I don't know what latest algorithm they are releasing, but yes, they have not spoken much about it. But I don't know how effective this is going to be. But summarization is still a problem area for all of us. Now, other than this, the question to you all is where all you think summarization would help. Let's talk about the problem. See, my point is if it's not applicable to most of the industry and if it's not effective to most of the industry, what's the point in doing this for the sake of it? So now tell me one such scenario where you really feel it's a need for the business, it's a need for the industry. Tell me one where summarization will be helpful. And it shouldn't be a luxury. I know it's good to have always, but tell me in which of the business areas it's a need. Summarization is a need and we are not able to do it at scale.
So in the healthcare industry, like suppose uh, we have old records of a patient, and if a patient goes to a new doctor or a hospital and they want to know his details, they can't go through all the records. I mean, it is a tedious process. So in that case, summarization is helpful.
What if while we are summarizing, let's say a particular patient has some XYZ low. What if the summarizer misses it while summarizing? So I think getting into healthcare, forget about for unstructured data or summarization. Getting into healthcare with AI, it's another big game. I would say another next 5 years. Right now, I think yeah, there are a lot of companies who are using AI to identify a lot of diseases at very initial stage. I agree. Computer vision has played a vital role, no doubt there. But when it comes to text and structured data, we are not yet there. So I disagree with healthcare totally.
So one use case could be doctors usually don't go through all the report. They just need the vital information or the
Correct.
vital parameters. So
Correct.
summarizing that using AI could be one use case for healthcare.
It's just filtering out or it's just extracting the table from the reports.
Right, right, right.
Right? It's not a summarization problem. So summarization, when I mean summarization, what I mean is you have 10K words with you. As an output, I want 10 words. This is my summarization concept.
Legal.
Legal. Good. Who was it?
Srihari.
Awesome. Good. This is the only industry where people are finding it useful. If I show you, wait, you don't believe. Okay, so forget about you having a package or a library. People have started building companies on top of it. Now, here, it's free.
Hmm.
Again, they have used BERT or any of this, right? I'll show you. We'll be implementing it. They've just made it as an API. They have given a UI. They have integrated it. Put your this. You get your summary here. Done. You don't even need a code, right? You can try it out yourself, right? Put your text here and see how the summary looks like. Again, it has two, short and long. You can get both the summaries. Right? So like that in legal, I think there are few companies who are. I know one company. My friend was working there, so that's how I know it's been cracked there. I think that they're getting pretty good results as well. Affine. I'm sure you know Affine company, right? Affine Analytics. Even they are doing. They have built it, right? And they have even published the code. It's straightforward. Even we'll build it right away. But my point is, at least in my experience, I have rarely solved problem with summarization. I've never worked with legal domain. Like Shriri mentioned, yes, there is a lot of scope there. I agree. But other than that, I don't know. Maybe I've worked with rest of every other industry. I've not done summarization much myself. Okay. Now I think Google's this release will be the game changer. I believe. Let's see. Okay. Any other case? Healthcare, I agree. Sorry, healthcare, I don't agree. Legal, I agree.
Coming up with summary of the textbooks.
Okay. Let's say
So
who is the target audience? Who is gonna use it?
So target audience could be student. So there are many books which are, the student may not go through even during the course, and there are books which are very smaller, which student can repeat again and again.
Okay. And my question is, you are maybe spending 100K to build a summarizer. Do you think you would get returns for it?
Education industry is fastest growing. So in this one of the fastest growing industries. So if we can generalize that, we can.
So whom you gonna sell this to? Say students. I don't know if they're gonna buy it or not. Or you gonna sell it to the educational institutes to summarize your notes and books and give it to your students. I mean, who is your target audience?
Target audience should be students. So just before the exam, I've seen many students, at least 60% of the students going through the school, mostly school and college, going through the not through the standard textbooks. They go through the smaller ones, smaller and lighter versions of those. And
Okay.
even in any education, right from schooling till college.
Okay. Anywhere else?
No, no,
Valid
but
point.
on the same thing, I want to just improvise that. So maybe a lot of people who want to pursue their doctoral degree, the first thing they have to do is lot of literature survey. So in literature survey, this will help text
Good.
summarization.
Good. Research papers.
Yeah.
Good. Good. Well, this is being used.
Okay.
I've seen my friends themselves doing it. So I agree. But again, you look from any angle
Means
other
from
than
business point of view, it may not be so much sellable.
correct. Exactly. So if you actually look at it, right, other than legal, whatever you're gonna learn or whatever you're gonna implement is not gonna bring you so much of ROI. Other than
Mm,
this legal, nowhere you see
mm.
ROI. Healthcare, I agree, there is a lot of ROI, but you have to be really, really accurate.
But at the same time, in healthcare, at least there will be already summary made by doctors or previous reports. So on the text
Yeah.
side, I too don't find um, means at like with my limited knowledge, I don't. Um, okay.
So this is the state. So I just want to give you that uh, cautious symbol that yes, whatever you're learning might not be much useful for the industry on the summarization part. But yes, if you want to do it for a like how Google is doing, right? So Google is just giving it against all the Word document or all the Google Docs and everything. So if you want a summary, you can use it however you want. They're giving it for free because they want to just have their brand for AI. If that is the intent, go ahead. But otherwise, there's not much. So only thing which is pending here is making it up to the mark, giving it the level of intelligence which human has. Right now, in summarization, there are two types: extractive, abstractive. What is extractive? Summarization are two types: extractive and abstractive. What is extractive? Any guesses?
Mm, Abstractive could be at a very high level, so only not going to so details.
So now maybe I'll make again under extractive we will have short, long. Again under abstractive we'll have short, long.
So going by that pure definition,
Hmm.
abstract, we are able to write abstract when we are able to understand the article properly, and extractive we may not have understood the article. Uh, yeah, some key phrases or something like this. But abstract for writing abstract, we must understand the article completely.
Okay, good. I like it. So fantastic, Soumya. I think you were pretty much right with the definition. So extractive is like the name says, you just extract important words, phrases, or sentence from the given article and show it as a summary. Abstractive means you read the whole content or an article and then write summary in your own language from what you understand. So this is human intelligence summary. Okay. So now for today, we're gonna just talk about this. This has been since years. This is no brainer. Anybody can do it. And even AI does it with great accuracy. So far, what I spoke about here and the summarization, the problem and all of it was on the abstractive side. Make sense? And this abstractive we will visit on day at the end of day 3 or beginning of day 4. Not now. Because I'm going in a flow, right? I'm going from an easy things to more complex things. That's how I framed these 4 days. So now we will just focus on extractive summarization. That's wherein there are a lot of readily available libraries. One such most popular and common library is, any guesses? Everybody is doing it now. Every library is doing it. But the most common
But
or the sorry?
but
No. BERT falls under abstractive.
okay.
So okay, I think this is really good. Abstractive summarization, input document, like Soumya mentioned, understand context, capture the relationship or semantics, create an own summary. Extractive, input document, sentence similarity, weight sentences, select sentences with higher rank. So now we just gonna focus on the easier ones. Okay. So now, again, these guys are building it from scratch using cosine similarity metrics, and then generate summary by extracting tokens and then ranking it. Here is a complete code for doing it. But then we have it pretty, I mean, for us, it's easy now. So I'll only show the code, right? So here, this record linkage is done, summary. So what I'm doing is I want to summarize Wikipedia's NLP page. Okay. So like you learned, I'll use beautiful soup to capture all the content from this URL. And then I'll use Gensim. That's it. Gemsim.summarizer. You pass in your input, and then it will tell you the output. Simple. Then you have Summy, which does the summarization task for you again. So now over to you, Santosh. Let's try running this and see how the summary looks like. And let us actually validate if we like those summaries or not.
Sharing my screen.
So how extractive summarization work? Can anyone help me summarize that? How extractive summarization work?
It works by extracting the key phrases and sentences in given text.
Correct. How? How will algorithm know which are the key sentences or phrases or words? How?
Maybe frequently occurring base word.
Okay, good. Next. Again, three things it does: tokenization, similarity, ranking. That's it.
Could you please repeat, sir?
Tokenization, where you get your tokens. Similarity, ranking. So then you take the similarity. Oh, and from each of the words, how many times NLP or maybe let's say text processing was used? Oh, text processing was used in most of the sentences, right? Oh, then it is ranking higher. Okay, let me maybe put it in even more simpler way. Let's assume you have 10 sentences. Okay, now you take sentence one and compare it with rest of the sentences. You get the similarity, correct? Yes.
Yes.
Now you do n cross n. Same you do with the second sentence with rest of the sentences, third sentence with rest of the sentences. You do the same n cross n and then you rank it. Then you will know which of the sentences have the most similarity against rest of the sentences. You pick that as the most important sentence for you and show it as the first sentence in your summary. And then the second one, then the third one. Then you club it with against how many words you want to show. And that's about it. Simple. There is no rocket science here. You'll not even know, oh, whether it picked an important word for me or not. Because there is no semantics, there is no context there. It's just a deterministic way of doing things. Right now, what is the summary we are getting here? Scroll down. Okay, you have read your this is your content of an NLP. Now, according to you, what should be the summary?
I'm facing some issues, sir.
Cannot import has pattern from Gensim. Oh, again, this is changed. Just see how your summarization, gensim.summarization, just go to gensim.summarization in Google and see how to import the summarizer. Yes. Or just put in your error. You'll get the answer. So this is the major issue while you put your code in the production. Right? So this is one such bottleneck every company faces while their code is in production, and it hits a roadblock because of the updates in the libraries or the changes what they make in the libraries. So that's wherein before every prediction cycle you have to ensure or you need to write a unit test case which will pass through all of it so that your prediction pipeline doesn't break every month or whatever frequency your prediction pipeline is running. It says that some version has a problem.
Yes, sir.
Okay.
Where are we facing problem?
Importing summarize from the Gensim summarizer.
Okay, because on Colab I'm able to execute that.
Yeah, it's something to do with the local environment, local variables and environment with the package.
Soumya, can you share if it is okay?
So what is the summary you're getting, Soumya?
So the keywords when I print, yeah, this last line, it is giving me learn, cognitive, cognition, NLP, and there are many.
No. I want to see the summary. I
Should
want
I?
to. I don't know the keywords. I want the summary. Yeah, please share your screen.
Yep, yep.
So these are the important words. I agree, but summary. I want the summary. Print the above one. Print the summary part. Yes.
Yes.
Take the whole thing.
Yep.
Yes. Yes. The proposed text includes a task that involves the automated interpretation and generation of natural language. The premise of symbolic NLP is well summarized by John Chinese Room Experiment, given a collection. If you were in that place, Somya, would you summarize in this way?
No.
Now you tell me what is the use of such summarization? Yes.
Just to give a bad example.
Right. So, I mean, my point here is don't promise any businesses that you're going to help them summarize stuff. We can never crock. If you ask me, can I write a algorithm what Google is doing it now? No, I'm not capable to do that. We are only capable to leverage state of the art libraries. Yeah, if you ask me to write my own library for random forest or neural networks, I'll do it. But if I go beyond from there, if you ask me to write my own algorithm for LSTM, I'm not capable. I might give it a try to writing my own algorithm for LSTM, but I might not be that successful as well. Right? So what I'm trying to say is we should know our limits and strengths in terms of where we want to play. Now, if this interests you, I'm telling you, summarization is still a problem. If this interests you, I can, if you feel that you can crack this problem, you can bring in the human level of intelligence while summarizing, go ahead for it. It's a research space. So people who are interested in research space, please dig deeper into this summarization problem. It's still not solved to the extent business or human expect. However, on the other side, text generation is working really great. And you all might have witnessed already. Autocomplete, Gmail emails, and all of it, right? So yeah, so this is extractive. Maybe Soumya, scroll down and you can try the other one.
Yep.
Okay. Now another library. Maybe again the ranking algorithms, what they use is different, but otherwise our approach is same. Maybe you can try with some of your own documents and see how things look like. Oh, you need NLTK. You do download NLTK, don't download this. Yes.
Yep.
So most of the libraries, most of the NLP libraries base are still NLTK. So NLTK by default you need to have in place. The whole NLTK package.
So it has printed the sentence.
By any chance, is it making sense? No.
Yep. Only thing shorter, it could be shorter compared to the original text, except for that, nothing much.
Correct. Right. So extractive summarization anyways is not going to help us. We just learn it for the sake of it. Since it's in the book, it's in the syllabus, we learn it. Just that you need to know, okay, there is some way of extractive summarization. Other than that, it's of no use. I'm being straightforward. You need not spend a time on it. I'm sure at least for next 5 years, you'll not be solving any problems around this. And maybe if your interest is, oh, I can build one such summarizer which is equal to human level intelligence, welcome. That's a problem area. I agree. Okay. Now,
So Akshay, at least the extraction part, are we able to do it successfully? Let's say if I want to scan out some legal documents and identify and extract out only a certain portion, uh, let us say like if like pertaining only to a specific task or something like that. So with only specific text, if we want to extract out as it is that feasible?
I mean, with extractive, it is not because you don't have a control over what the text you're looking for. Do you agree with me?
Yeah, the reason why I'm asking this is because uh, within my company, there's this extraction related task which they are working on. So they're trying to use BERT models for it. And the problem is like we have legal documents, like the customers have signed with their suppliers, and there are some things called deliverables, obligations, and also uh, we are trying to extract that out.
Hmm.
There is a lot
So
of data
correct,
where
correct. So what is your requirement in terms of extraction? Is there any particular things what you want to extract?
yes, when we say a deliverable, say if I want to, if my deliverable is that say I want to deliver some reports or MIS related tasks, so I should be able to identify if it is a task which has to be delivered, or is it an obligation on that task, or a restriction, something like that. Basically it is capturing context on uh, based on the deliverable or obligation.
And based on that, you take your sentences out.
Yeah,
Correct?
exact sentences as it is. Yes.
As it is. Correct, correct. So see, okay, now, uh, okay, good problem. This is not extractive summarization, by the way. Okay, let me share my screen.
Okay.
I've
Yeah.
solved a similar problem before. I don't have that deck handy, otherwise I would have shown. I've solved one problem around it in the past, 3 years back. But let me explain it. So now I'll talk about that problem. Okay. So, or just a second, give me a second. I think I'll just search for the document if I have it handy. It becomes easy. Uh,
Okay.
so it's about tagging the right context. And then once you decide, okay, it's whether on A or B or C, what is it you're looking for? From that, you extract the sentences. Am I getting your problem right?
Yes, Akshay. Like another simple example would be, say if we have SLS provided in a document, so my model should be able to identify that SLS. If a table is provided or text is provided, it should be able to extract that portion out.
Hmm. Okay. No, no, I've solved a similar problem before. Just a second. I don't know where I kept it.
Sir, just curious to know,
Mhm.
how many problems till now you have solved in the ship problems? You already shared lot many with us. Just wanted to know
Yeah, so
total numbers.
yeah, I'm again, right, like the way I'm getting into all of this, I'm just talking from my experience. I'm not referring to anything or I'm teaching, right? So whatever I'm conveying you with respect to those topics, I'm pretty much covering whatever from my experiences, right? So I don't know, man. I don't really have a count of how many,
Okay.
but currently, if you ask me, yes, from last 6 months, I have 27 clients with me. backgrounds, different domains, so I'm solving different problems.
In a month?
Within
So
just 6 months, is it?
yes.
Okay.
So wait, I'll show you that. So I put that in one of my next book. The book I'm gonna share you, right? I've already shared you one book, The Fundamentals of NLP. I'm gonna share you the next book on NLP, maybe next week. And in that book, I have covered that problem. So I'm just trying to find it from the chapter itself so that I can show you right away. I think it's very similar problem what we did.
We have another book of yours in LMS which says NLP recipes.
Yeah, that's the one which I shared with you last time also.
Yeah.
But I have not shared the another book. Okay, so let me see if I have it in this chapter. Okay, so this abstractive, I'll be covering the same from my next book only. I'm sharing my screen. Let me know once it's up. So this
Yeah,
is
we can see.
the next book which I'm going to share. From that, yes, it's a whole chapter on summarization, wherein the title is news headline summarization. So it could be long, short. These are the examples. What is approach? Extractive. We covered extractive. Here is a simple example, right? Source text. Oh, this. Extractive. Varun went to attend data science event about data science. That's it. It just extract few important words. Now, how it works? Like I said, it could be using similarity plus your rank, text rank, lex rank. These are the ranking algorithms, what it uses. So GenSim is a popularly used. Abstractive, where you write in your own language. Yes. Oh no, I've made it simpler here. So the problem was before that there was another problem, right? Wherein you have to identify what topic they are talking about. So, or what topic they are asking about. Let's say we in our inventory we have 5 topics. Topic 1, topic 2, topic 3, topic 4, topic 5. Maybe 5 categories. And if there is a question from any of those topics, now how do I know from where I need to pick? Correct. So first, I think it was Ritvik, right? So like Ritvik mentioned, we need to identify the context in which the person is talking or asking about. Then we tag it to that particular concept. And from those concepts, either you do an extractive summarization or abstractive summarization. Right? So this is the approach what I'm taking here. You pre-process it, you put a document, you pre-process it, and then you do a summarization, which is abstractive. There are 2 types. One is you use pre-trained models from Google or Microsoft and then just generate the summary directly with 2 lines of code. The other one is where you want to custom train or your node data based on the pre-trained model. So we have BART and T5. Most popular libraries and algorithms which will help you do abstractive summarization. Again, these are cracked by Google, Facebook, and whoever has the most unstructured data in the world. And then on top of it, there are a lot of flaws with that, right? Cons. Then that's wherein you apply Roberta, which will help you post process, where you remove the redundancy, you do the grammar check because your summary has to be accurate, at least from a English standpoint. So that's wherein you need to do some post processing to get the final summary output. So this is how I solved for one of the clients, and I put the same in this book. The whole topic. So TY and BART. It's there. It's simple. It's straightforward. And even how it works, right? I'll explain you. So if you know, I'm sure you might have learned bidirectional LSTM, autoencoders, attention mechanism. Yes.
No, sir. We've learned encoders and decoders, but not attention mechanism.
Okay. Okay. Then I'll explain you this. So again, like I said, this should be on day 4. So I'll get into the again, like I said, right? So day 1, day 2 will mostly focus on machine learning and NLP. Day 3, day 4 will focus on deep learning and NLP. Okay, all this comes under deep learning. So BART, again, they use transformers. You have learned transformers in deep learning?
No.
Okay. I'll try my best to cover as much as algorithms we can from deep learning, and then T5 is another pre-trained model where you just give the text to it and it gives you the summary. It's that simple, right? So this is huge. So it's like what, 25 page just abstractive summarization, right? So
Okay.
I still did not get what I wanted to show you, Ritvik, but I just put it in the relevant things here. I did not put the whole problem what I faced for one particular company. So, anyways, okay, we'll talk about more in detail when we actually do the abstractive summarization.
Yeah, sure, sure. Another reason is because I've reached out to my company for helping me out with the data for Capstone project, and this is what they have suggested. So they said they'll be sharing some
No. Pick
dummified
this as
data.
your capstone project for sure. Let's solve it.
Yeah, there's
Okay.
no official confirmation yet, so I'm waiting for a confirmation from my company side.
Okay. All right. It's a pretty
Okay.
easy, straightforward. See, extracting summarization is no big deal, be it extractive or abstractive. The problem is how do you fit in this problem into a bigger picture? Your problem is something else. You're just trying to fit in summarization in between there, Ritvik.
Yes, yes.
Correct? Exactly. That's what I'm interested in more, not the summarization part of it.
Yeah, I know pretty well where it fits because I've
Yeah,
been
yeah.
in the domain for 4 years.
Correct. Now, one more thing. Now, if you all would be wondering, right? Uh, have you ever tried this? Let us try this together. So, let's say I type something. What should I be typing? Hmm. Okay. Now, against each of this website, you get some content. What are these? Are these the first to one or two sentences from the blog? Let's have a look. If that's your Rahul Dravid and Sachin Tendulkar hold the record of most. Sachin Tendulkar had tried a most successful combination in the history. Sachin Tendulkar. Okay, this is the first sentence we picked. Top 10, the only player in the list to have been scored. Okay, this is not. This is the starting sentence. It's somewhere here, the only player. It should be somewhere in between. So now you tell me how these are being picked. You always thought that, oh, these are the top sentences from that or the first few sentences of that document.
I thought like that, but I've done few searches where it is picking from middle. So it
Correct.
relates to the search what we have provided.
Correct. So again, isn't it extractive summarization where it checks for the similarity and then ranks it?
Right. It
Correct.
also provides the best summary on the top search result.
Here, yes. So that's what I'm saying, right? If anybody in this world who could crack the summarization to a level of human intelligence, it has to be only Google. Nobody else could do it. And I think they have cracked it. I've not used their recent one, what they're claiming a month ago. I've not used that, but I think they might have had the best one out. Okay. So this is on the summarization part. So let's discuss further on the summarization when we get into abstractive. Okay. So now my fifth problem to you for the day is assume you're in the same problem. Assume you're in the same problem which we discussed this morning. Okay. Now There's a company which is a competitor of HDFC, let's say Kotak. It's 2015 where HDFC is facing this problem and you solve it using this method. We already solved it in the first half. You all implemented it. Agreed? Now, Kotak started its banking industry. They just started. It's been 3 months. CEO of Kotak is a good friend of HDFC CEO. He tells him, hey, look, I've solved this problem with AI. I used to spend 100 or maybe let's say, 100K every month on the resources, $100K. Soumya and Santosh came to me as AI consultant and I just spent $50K and my problem is solved in 2 months. Now AI is doing everything. I'm saving a lot, 90% of my yearly operation cost. HDFC CEO tells it to Kotak CEO. And what Kotak CEO does? He just tells AI help me solve this. What Kotak CEO does? He contacts Soumya and Santosh and says, hey, look, even I've started my new business into banking, what HDFC is doing. I'm doing the same things. And I'm planning to hire 50K support engineers to do this job for me. But one of my HDFC friend mentioned that you solve those problems with AI. Can you do the same for me? This is the problem. How do you approach it? Yes, how do you approach it? Okay, first of all, is my problem clear? Can you all hear me?
So the Kotak Bank wants to replicate what HDFC did?
Yes. So Kotak said you, right? They are saying you, see, I heard that you did great things using AI to HDFC and they are able to solve 90% of their operation cost. I've started my new business. Basically, Kotaks are new in the business. It's been 3 months and I'm yet to hire 50K, support engineers who can do this job for me. This manually navigating the complaints to a respective department. Now, before I could even hire, can you solve this problem to me?
It's like they are only 3 months in the business.
Okay. Yes.
We don't have a part of a data set. Actually, in HDFC, what they have did for 5 complaints, that record will not get from the Kotak.
Correct.
Historical
So,
data.
yes. So which means that, yeah, you might have the historical data, but you might not have the labeled ones.
Yeah.
You might have some
Okay.
complaints with you, but there is no one who could label it for you, like HDFC did it for 5 years. So what would you do? So would you, since you know that they are into same businesses, the complaint might also be the same. The categories are almost same. So you will, since you know the HDFC, the problem what you solved for HDFC, you have those data in the local. So you will tell that, oh, I have HDFC data with me. I'll use that model and I'll give it to you. Can you say that?
No.
Why?
Compliance issues.
Next day you'll be in the jail. Right? So You cannot do that. Now, what would you do?
Maybe earlier what HDFC was doing is maybe now in Kotak what we can do is while complaint is raising only we can tell the customer example if they are raising a complaint through some tool. In that tool only we can suggest which category you want to
Huh,
raise a complaint.
correct, correct. But the problem is you will not even know. Maybe this is intuitive. Maybe my example is naive.
Okay. Okay.
This is intuitive, right? If you're raising complaint
Mm,
against this, but there are some cases where you wouldn't know their banking terminologies or categories,
got it, sir.
right? Within savings only, there might be a lot of such products. So you would not even know which product your complaint might go to. I mean, see, I'm not just creating this problem here. This problem happens to everybody. I'll tell you, you help some companies make money. Trust me, you're gonna get a lot of referrals. If Kotak was CEO was an AI person, he wouldn't have even come to you because he would have had a knowledge that, oh look, oh they solved it because they had label data, and to build the classifier you need a label data, which I don't have. So probably I need to wait for a year or so to do this manually, and then I can do this. But they are not. For them, AI is magic. HDFC CEO told, oh, AI did a magic for me. It will do magic for you. Go and contact them. That's how this industry works. I'm telling you. Now, would you say that, oh no, it's not gonna work? You do it for 1 year manually. Give the label data with me. Okay, once you get the label data, come back to me. I'll solve this. Is that what your response is gonna be?
No, sir.
Then
Maybe we'll generate. Maybe we'll ask all the whatever the categories they have and all. Maybe we'll generate the some kind of data, and based on
no,
that we will.
no,
No, okay.
no.
Maybe take a survey from the existing customers.
No. Is Sandeep on call by any chance? I think he's not there. He already answered it when we started this session. Just try to connect the dots. You have the answer within you.
You mean the unsupervised approach which he was speaking about?
Yes. Yes. You don't have label, that's okay. We can still solve it through unsupervised approach. And by extracting the keywords. You agree?
Yes, sir. Yeah.
Yes.
Okay. Correct. So that's wherein always remember, whenever you have this problem of label data, unsupervised is an easier approach.
Okay, sir.
I believe this was covered thoroughly in your machine learning module, right? How, when, where you could apply unsupervised. Right? So with that note, let me, I think, go to the solution page. So where is that? Or summarizing is clustering documents. Okay. So now we are talking about, we are done with classification, binary, multi-label. We are done with sentiment. We are done with your similarity. We are done with summarization, extractive summarization. Now we are into clustering. Now I'm just posing a problem which is naive but relevant. But other than this, clustering documents have lot of scope. One is this, and then suppose let's say you want to group all the documents in a library, online library. You want to group all the documents and give a name to it. Very, very, very important use case. How do you do that? And even go for analytics vidya, your analytics India magazine, your medium, your towards data science. How would you logically group all the blogs or articles or the books together? You'll not even know the category. You cannot even do a classification there. So I'll explain you to this journey, right? So again, here I'm just taking that I have a narrative, nothing else. I don't have anything, any other data with me. I just have complaints. I'm using the same data set, consumer complaints. So I'll use just the narrative, right? And then I'll tokenize stem, I'll, do whatever. And then I'll convert those into features, TF-IDF. Once that is done, I'll run through k-means. How do you decide that I need 6 number of clusters? How do you decide number of clusters? I believe you all know how k-means work.
The elbow.
What is elbow?
It's the plot where we see, which we use to identify from where the amount of information that we are extracting becomes stagnant, even if we increase the number of cluster centers.
No, no. Is k-means not covered? What does silence mean? Is that you all are sleeping, or is that you are not interested, or is that you want to close for today?
We there was something like, I'm not able to recall, but something like elbow method, and so
The knee plot.
yeah, we'll plot that, and to find the optimum value of k. So the graph was more or less, if it starts going horizontal, that time we will stop, but I'm not able to recall exactly. We will plot with different values of k for that.
Okay, yeah, correct. That is elbow method, but how k-means work?
So we try to divide we define the number of clusters, and then we start with any centroid. Then we, uh, uh, I mean, when n number of centroids with any, I mean 6 centroids in this example. Then we, within that cluster, we try to find the minimal distance centroid, and we push the current centroid to that minimal distance centroid in the
Correct.
next iteration, and keep
Yes,
on doing that.
correct. Until your cluster stabilizes. Centroid, cluster centroid stabilizes, right? Good. K-means clustering, I think they have a good uh, this one, just to show you the visual. Um,
Where the centroids were moving.
correct, correct, correct. So I just want to show you, right? Oh man, this is if you look at it, right, it's doing k-means iteration, and then the centroids are moving. This is another good example. This is right. The k-means is really awesome. I like this algorithm, right? So any given state, you should be able to explain this how it works. Very important and very easy. Right? How why the centroids keeps on changing and how these are getting assigned to each individual centroid, and can this be changed against each of these? Right? So this iteration keeps on happening until this k-means is stabilized. Now, how do you decide when to stop? What does this L mean? What does that L mean? The distance between the centroids are higher compared to the distance between the point and the centroid. So this is basically error definition in k-means. Okay, so let's not much worry about it, but the overall point is, yes, you run the k-means on that document. Now, what you do get after running k-means? What is the output? So I had the complaints data with me. I cleaned the complaint data, complaint narrative. After that, I did a text to features, and then I'm running k-means. After that, what is the output?
Group of 6.
Correct. So you'll
Yeah.
have group of 6 complaints. Correct? You're
Yes,
right.
sir.
Now, what next? What next? Did I solve their problem? What the problem by Kotak is? Did I solve the problem with this?
Not yet.
Okay, then what I need to do next? So you have the output with you. What did you do next?
So
Or
we'll test
Some
it. Suppose a new request comes in, we'll try to group that into one of the existing six of one of the six
correct?
clusters, and then we will take feedback from the team, the SME, whether this grouping is correct or not for the new data.
Okay, now how do you do grouping? How do you name the group? Okay, what did you do in your structured data for k-means? What after this? Okay, fine. Now your output is like this. Your output is complaint one, whatever the narrative is, right? The complaint two narrative, the complaint three narrative. Okay, this belongs to cluster one, this belongs to cluster two, this belongs to cluster one, so on for all the data set. This is my output. What next? Suppose if you are doing a clustering for the structured data, you get the same output. What next? Correct? These two should be our next logical steps of clustering.
Yep.
Did you do that for your structured data? Okay, forget about this text clustering. What are the applications of clustering in the industry? Where all do you think can be used? Quick, I need quick five.
Like customized offers, customized credit card offers to
How?
customers.
How? Okay,
Based on
what?
the behavior of customer, like if he's kind of traveling more or online shopping is more,
Correct. So what you do? Again, you do clustering, right? So you have your data where you have all the relevant features with you, and then you do the clustering. You have the cluster output. Now, this cluster output is cluster one for this customer, customer one. How do you know that what offer I need to put for him? Customized offer. There is no relation between what the business is expecting from me and what you are doing here. Just by giving cluster name doesn't help you with anything.
We need to understand this, as you mentioned, cluster features or the properties.
Correct.
If we are using it for, say, fraud detection, this cluster belongs to fraudulent people, other one doesn't belong to fraudulent people, and so on.
Right. So basically, you dig deeper into those features and try to extract the properties. Oh, cluster one, shop. Let's say it's a Flipkart data. I'll make it even more simpler for you. Maybe I could sense that you have not got the grip of this. I'll try to explain, right? So what all details can be there? What are the products you bought? What category that product belong to, right? And then what is the amount you spent, whether you spend on a weekday or weekend, right? And then so on and so forth. Let's keep it very simple, only these, correct? Now, once I get the cluster, I need to understand the cluster properties. How do I do that? I'm sure you might have learned it. Once I extract the cluster properties, I'll get to know, oh, cluster one people are mostly into jewelries. They buy jewelries from Flipkart. And they spend high. And they mostly shop on weekend. So I will name these guys as high value jewelry buyers who mostly come on weekend. Then cluster two. So these mostly, they are into groceries. They mostly buy groceries. And then their frequency is maybe once a month. And then they don't spend much, they are low value. And then cluster three, again, they are mostly into groceries and they are high value, but they spend high amount on us. So like this, you'll extract all the properties. Once you get all the properties of them, you name them, cluster them accordingly, right? So in my experience, I usually go with high value, medium value, and low value, along with putting them as platinum, gold, and silver, whatever, right? So that I'll give a definition of all of this naming, because I cannot keep on putting a sentences for each of the cluster, right? Then I'll give them a legend saying, okay, if this is platinum, this is what it means. Now looking at these properties, they'll roll out an offer. They'll roll out a customized offer. Does that make sense? Yes.
Yes.
Clustering is predominantly used in marketing strategies. Very, very important. Every single company in this world are using clustering on their customers for building up the marketing strategies. Okay. So now you know that how do you extract the properties and how do you name them, right? So now we have to do the same thing for text. Once you have this complaint, once you have that cluster being named, how do you extract properties here? You extract properties here by doing word cloud or top keyword extraction or most frequently used keyword, and you build a keyword word cloud. So now going back, this is done. Now I want to take the similarity and then try to put the cluster names. Property based assist. These are the top three keywords for cluster 0. Cluster 1, business card, were the top two words. Cluster 2, authorized, approved, believe, were the top three words. For cluster 3, agreement, application, business. 4. Again, these are not accurate, but I think can be a good starting point on what Soumya mentioned, right? So Soumya did mention, so based on when the new complaint comes, I'll tag it to a particular cluster, and whatever the cluster name is, I'll tag it to that particular department. Again, there might be a room for errors, but that's okay. In 2-3 months, our algorithms will learn, and then we can convert unsupervised to supervised. Clear? Does it make sense? Yes, no.
Yes, sir.
Yes, sir.
Are you clear with clustering documents? Now, same goes with your library, online library clustering documents, right? Now, so you don't know what category or what tag to give it to. So based on the cluster properties, you give them, oh, if this is mostly into comics, or maybe let's say horror or whatever genre books, or maybe this is into mostly startups, motivational, inspirational. So those are the keywords you start getting from the book documents. So based on the keywords, what you get from each of the clusters, you name that cluster accordingly. So this will help you conceptually group documents into relevant grouping and then give a name to it based on the cluster properties. Is that clear?
Yes, sir.
Yes. So I believe you all have implemented the word cloud and top frequency words and all of it in the unstructured.
Yes.
Yes,
Okay,
sir.
great. So now with this, we are good with clustering. Now I'll again reiterate. So point number 1. Observation and performance window. This is nothing to do with NLP. This is all ML. So this you have to explore, and I'll be asking the question around this. Point number 2. I think we discussed something else also, right? Naive bias. Naive bias. I think Soumya already answered it. Was there something else which we were supposed to discuss? I think did somebody take a note of it?
Something
I wrote-
explanatory ML, how to infer the result of the
Explainable AI.
Okay,
explain.
explainable. No, no, explainable. I think it's difficult for you. I'll cover it myself. It's on me. I'll cover it. You don't have to explore. Explainable AI, I'll cover it. Okay, I'll try to fit in this for day 4. Okay, now I'm just talking on the assignments part. So this is 1. We'll start with this ML discussion, performance observation window, and then there was one more I forgot.
When the churn will happen.
Correct, correct. That's it. That is what it is.
Okay.
That is what it is. So I'm giving you the solution name as well. You just need to explore about it. Okay, this is the solution, observation and performance window. The answer is that, but you need to explore how to do it. Okay, so then I'm just thinking, where is that? So I think there was something else we discussed. Decision tree, I think we discussed.
You asked us to list down all the applications and use cases of text classification
Correct, correct, correct.
across
Okay.
multiple industries.
So ML, there is nothing much, right? ML is done. ML only this. So now all NLP or text data applications, not text data applications or use cases across industry or domain. Okay, this is then third. No, this is for text classification. Third, pick one of the above and implement end-to-end. Clear? Maybe let's say product catalog. Someone can already pick the product categorization, which we discussed last time. It's a simple multi-class classification problem. And like that, you'll have a lot of problem. Choose the data for it. You'll get a lot of open source data and then try to solve one end-to-end. Is that clear?
Yes, sir.
Implement record linkage end-to-end because we have not run it in the class. Fifth, summarization. No, I don't want to give any assignments on summarization, extractive summarization. And then fifth point is, I want you to list all NLP not application use cases. Yes, all applications or use cases for clustering. So we discussed one complaint and then we discussed what is that? The other one. Online library grouping, right? And then you implement end-to-end. Implement clustering end-to-end on any of the above applications what you might have listed. Try to find the data from open source and then implement it. Is that clear? So see, these are the 6 things what we are supposed to do before we meet next.
Sure, sir.
Okay. So now, what are the things or important things we are left with? Classification, done. Analytics, statistics, that's pretty much. Again, whatever EDA you do, right? You do group by, you take the count, you put the block, bar plot against how many categories are there. That's about it. The word cloud. That's about the analytics there, right? You did the clustering. You did half summarization, which is extractive. You did half or 1/4 of similarity. We're gonna do a lot in the similarity. The basic similarity we did, we're gonna do some advanced similarity further, right? So these are the things what we completed. Now, detailed summarization we'll revisit later, the abstractive one. Search engine recommendations and all of it will do day 3 for first thing. We'll cover similarity, the overall concept, and then we'll move on to text generation. Now, before that, what is this regression? To be frank, I have never done regression on text in my experience so far. But it's good to be discussed. And I don't even have a code for it, to be frank with you. But let's discuss about it, how it can be formulated. So let's do it together. Okay. So now, what is regression? And then let's talk about what is text regression. What is regression?
Basically, finding the relationship between the known, between the independent and dependent variables.
What kind of variables? Or what kind of variable is your target variable?
It's
Numeric.
continuous.
Numeric.
Continuous.
Yes, numeric. Fantastic. Okay, so this is regression. You all know what is regression. Good. Now, how do you think it can be applied on text? How do you think we could apply on the text? It's easy. It's relatable. We already encountered such, or already we discussed about problems in that area.
we can use it for classification. I mean, we know only uh, say the tone is negative or positive.
Hmm. No,
Word count.
no. Think about it. Think about it. It's again related to maybe let's say complaint use case or maybe something else.
Uh, Scores and confidences.
Correct. Yes. So maybe let me just quickly check what I discussed a year back with the other batch. Resale settlement value. I don't even remember what I discussed with them. Okay, anyways. So right now, what we can do is maybe let me think a bit louder. Okay. So you have this complaint data, right? If you actually look at the complaint data, it also has the column on how much time it took to resolve. Correct? Correct? One has
Mm,
2 hours, 5 hours, 12 hours, 56 hours, 72 hours, 50 hours, or maybe 120 hours. Correct? Correct? So now
Yeah.
suppose let's say if you raise any ticket with one of the most popular enterprises or banks or whatever, it will tell you your ticket will be resolved in 12 hours, 14 hours, 20 hours. Correct? Right
Mm,
after you raise the ticket, it will tell you. Now we have the data with us where the complaint narrative is there with us. And then we also, let's assume we have another call which says it took how many hours if it's been captured. Because they'll in fact, even if it's not there, you can definitely calculate it yourself, right? Because it will tell you, okay, solved date and time. That is already there in the data. You can go and check, right? So the complaint raised time and then solved data and time. So this you already have. So difference between these two is the time taken. Correct? Correct?
yes.
Right? So I have this data with me. Time it took to resolve. So this is my text, input text. So whenever a new complaint comes in, if I build a model between the input complaint and the time it took to resolve, which I'm getting to these through columns, my target feature, which is a numerical value, obviously it's a regression problem. So I'll build a regression problem on this text and this target variable by converting this text into features. And once a new complaint comes in, it will throw me a number as an output, saying that, oh, for this complaint, it might take these many hours. Correct?
Yep.
Yes. So this is what and how, at least I could think how we can apply regression on text. There might be different use cases. Again, score indexes and all of it, like Siri mentioned, even those can be valid use cases. But at least in my experience, I have not solved much of a text regression. Not much, in fact, I have not solved any text regression problem in my experience. But I'm just thinking loud with you all on how it could be done. So your assignment number 7. There is too much of work for you guys this week because last week I did not give anything. Now I want this text regression case on the complaint data to be implemented on exactly what we discussed. Time it. You have the raised time or what what is your name? Santosh, can you share your screen? Let's figure out what are the columns we have. All right, so right away figure out the target column so that it becomes easy for you.
Sure.
Okay, so yes. So date received. We have the date received with us. Correct?
Yes.
Then scroll to the right. Oh man, date completed is not there. Date sent to the company. Are date sent to the company and date completed same? Yeah, it's almost same for most of the records.
Yes, sir.
Okay. Okay, I even doubt if we could find any data set on this. But you all got my point, is it? Yes, no. Did you understand the concept of
Yes,
text
we got this.
regression?
Yes.
Any doubts? Any questions on that? So if you have got it, if you have no doubts or question, I would put in, or maybe you can consider that date sent to the company as your submitted date or issue resolved date. Then you can take the difference between these two. And if it's same everywhere, then I think no point in solving it. But if these two are different, I think then we have a chance. So I'm sharing my screen. So text regression use case. I'll not say complaint data, but try to look for every data set using which we could solve it. Okay. So now the most important and pending things are, how do you apply deep learning for classification? When do you think I should be applying? So my next topic is, when do you apply deep learning for classification? So ML for NLP, I think we covered. Clustering we covered. Supervised and unsupervised, we covered both. But now, if I want to do classification, I want to apply deep learning models like LSTM. When do you think it would be useful? When do you think it would be useful? Yes, when I'm able to solve the text classification problem using these algorithms, why do you think I would need deep learning?
Like with ML algorithms, we still have challenges that if the text is long, the
No,
context is not
correct.
captured.
All the word is context. All I was looking for is context. You apply any kind of machine learning on top of TF-IDF or count vectorizer or 1 encoding, you lack the context. Big time. That's wherein if suppose let's say if the context is important for you, you know, right, based on the use case. River bank, you know the difference, right? If the bank is beside river, that's a different bank altogether. If the bank is somewhere else associated with the dollar value. You're getting my point?
Yep.
So whenever the context is important, it becomes a biggest challenge for these algorithms along with TF-IDF to solve the problem. And that's wherein, so how do you solve? So classification problem can be solved in two ways. So I'll call it as traditional text to features. What are traditional text to features? 1 encoding, count vectorizer, TF-IDF. Okay. So plus ML algorithms, where this is non-contextual. Next is SOTA text to features. What is SOTA text to features? We discussed it at the end of day 1.
State of the art.
I didn't ask for full form, Ritvik.
Okay. LSTMs.
No. Text to features, SOTA text to features. What are those? We discussed. I literally spent a lot of time on explaining the neural network again.
Word embeddings.
Exactly. You killed it. Right? I can show you, right? I think we discussed somewhere on day 1. I'm just trying to figure out where it is. Yes, here it is. Word to vec glow fast text. This is word embeddings. Right? I even explained to you how it is extracted. So along with that and ML, which is contextual, or if you actually look at it, why do I need to do these two when I can directly just do this? Correct? You all agree with me? Correct. This SOTA is based on neural network, isn't it?
Yes, sir.
Correct. So these are the 3 approaches on how do you solve a classification problem. Clear? Now we have done this so far. We will do these two on day 3. Okay. So how your day 3 looks like? We will cover deep learning and text to features SOTA for classification. Once deep learning for NLP is done, then we'll deep dive into search engines, another similarity application, or content based recommendation system. Are your recommendation systems done?
No, sir.
No, sir.
No, sir. It was covered a bit in basics in the linear algebra module.
So do you want me to touch upon recommendation systems?
Yes, sir.
Yes.
Okay. So is time series covered? You all know time series end to end?
It was covered in deep learning module and stats module which you took.
So time series you're good, right? So I'm just putting down what all I need to cover. So that I'll make some time for day 4. So that I'll probably, see, I'll make it very clear, right? For me, breadth is very important than depth. I always focus on breadth. I know depth you can figure out yourself. For me, it's important to make you all aware that yes, these kind of things can be solved. And I'll try to touch upon how, what, when, where at a high level. Because going in depth against each of the concept is impossible, given we have limited time, right? So breadth is always my focus. If you know at least that, oh, there exists something called as XYZ, you'll at least get deeper into it to solve it if there are some problems around, right? So now XAI is what I'll be touching upon. Since you asking for Rexis, I'll do Rexis as well. What else? Anything else you want me to touch upon? Which you feel you're uncomfortable with, or you feel you have some gaps with that? Only these two? Nothing else? In stats, anything? Do you know how to do hypothesis testing? Can you define me what is p-value? ML, I think we are touching upon here and there every day. So ML, I'm okay with. Okay, deep learning, I think we need to cover attention mechanism. Next. Anything else you want me to touch upon? Nothing?
Akshay, there are certain unknown unknowns.
As in?
So, I mean, I may not be even aware of those things. There are some things I know to cover, but there are some unknown unknowns which I think.
Okay, so let me do this. Wait. So this one, right? Okay, let's go one by one. Good with this, at least ML. Let me try to cover because it's fundamental. Good with linear.
Yes, sir.
Good with logistic.
Yes, sir.
Against all of this, what are the assumptions? Trigger what, why, how, and now. Maybe I'll leave it to you to figure out. Linear is done. Logistic is done. Decision tree.
Yeah.
Random forest.
Yes.
GBM.
No.
XGBoost.
Not much.
No.
ADA boost.
No.
No.
SVM.
Yes, to some extent.
Naive bias. KNN. Neural network. Yes. Can I skip those?
Yes.
Okay, great. So which means you know all of it, which is good. K means hierarchical, K prototype, K modes. All types of clustering done?
No.
Only K means.
Only K-means.
Oh. Okay.
Again,
So
neural networks, we covered some part of it, but I think being a vast topic, not everything could be covered.
what exactly you want to know from neural network?
So we mostly focus on the sequential part of neural network, building a neural network using transfer learning, and building ourselves using sequential layers.
Okay, so if you pinpoint any specific things on it, I might try covering those. But like you said, it's too vast. If I start from scratch, it will take days. So I'll leave it to you, Soumya. Pinpoint if there are anything specific you want me to cover, I'll definitely cover. This is my favorite subject though. Ask me anything around neural network, I can talk about it.
Sure.
Okay, and then PCA.
Done.
Quick. PCA.
Yes.
Done. Moving
PCA.
average, weighted moving average, ARIMA, Arimax, exponential smoothing, FB profit, ML based, LSTM based. All done.
FB profit.
Okay, next. Very important. FB profit, everybody is using it. Rest everything is done. Exponential smoothing, Arimax.
MA and WMA, I'm not sure.
No, that is moving average, weighted moving average. So in 1950s, 1960s, how people forecasted, they just took a moving average.
Okay.
Weighted moving average. You know moving average, right?
Yeah.
Yes.
Stats.
Yes. So then this is done. Next. Recommendation system. All this kind of recommendation system. Your a priori is not covered.
No.
No, sir. Association domain. No.
Okay. And then I think for recommendation system, we need a lot of time. Okay. Anyways, I put it here already. Recommendation system. That's the second priority. Okay. And then oversampling, undersampling, grid search, model tuning, cross validation, overfitting versus underfitting, bias variance trade-off, confusion matrix trade-off.
Yeah. These
Yeah.
things.
All done?
Covered.
Great.
Yes.
Explainable AI? I've already
No.
put in. Auto ML?
No, sir.
Yeah. H2O is covered.
One module
Yes.
there is two.
Okay, good. That's okay. That's enough. Observation and performance window?
Assignments.
No, anyways, I think we will be discussing that on day 3, right? I'll cover that. If you are not able to answer, I'll cover it. Where are my assignments? Where did I put in? Ha. So here, I've already given you the answer for that. But yeah, okay, that is done. Similarity algorithms, cosine similarity, Euclidean distance, and all of it.
Yeah, I mean, we discussed in this module.
No, ideally it should have been in detailed on how it works, how the distance is calculated, how you calculate the distance between two vectors.
So Euclidean distance was discussed.
See, one more thing. Okay, then okay, one distance algorithm I'm okay. Just one is okay. So see, that's what, right? I don't want any gaps because I'm covering these two from an application or an industry use case standpoint. This whole NLP module. Like I said, this NLP module is just about connecting the dots. You have learned everything. So I want to ensure that you know it. All right. This time period, ignore it. Kurtas's IQR, different ways of outlier deduction. Don't tell me these are not covered. Forget time period. This is nothing.
IQR, yes.
Discussed.
Different ways of dealing with outliers.
Yeah, we covered those things in NLP.
Kurtas's. Okay, this lands me to another question. Suppose, let's say, and types of features also covered, right? Numerical, categorical. Okay, tell me,
Yes.
what kind of Jesse number? 17, 18, 700. What kind of variable it is?
Categorical.
Category.
Isn't it not numerical? Numbers, man, they are numbers.
No, it's not continuous, and we cannot
It is continuous.
like each number identifies an individual from a team. That has to be categorical.
So, but I see numbers here. Why it can't be numerical? Did I ask this question before?
Yes, sir, in stats
Yeah.
class.
I did not take stats for you. Oh, I mean, someone else asked, is it? So
You
these are
took.
my questions. Did I take your
You took
stats?
stats.
So,
Yes.
Yes, yes.
Oh man. Okay, sorry. My bad. I forgot. Okay. So then yeah, outlier detection. This I have no doubt. So this is with ML, right? So now are you clear with this ML lifecycle? You know how to ask the right questions so that you define the problem in a right way. Because every time what happens when the business comes to you with some problem, but when you start asking questions, they'll realize there are more bigger problems than what they actually thought about. Then you translate into AI problem and approach. Then you do a milestones and planning, how much efforts each task would be taking. Then you gather the data and understand, then you do the prep, then you do the cleaning, then you do the EDA, then you do feature engineering and selection, then you do model assumptions, check, then you prepare the model data for model building, then you build the model, then you evaluate, test and tune, and then you predict, and then you deploy, and then you will have a feedback loop, then you do A/B testing. So are you clear of all of this AI/ML lifecycle?
I was not 100% clear on this, but as I said, Hasita has shared some of your previous sessions which you have taken for the previous batch.
Okay, go
In
through that.
that
Yes.
you've covered it detail.
Yeah,
Yeah.
go through
Then
this.
I got some clarity.
In the stats as well, you have
Okay.
covered these things.
Okay, great. So if this you have clarity, then you can solve any kind of problem. Okay. Most importantly, for me, the most important things, at least for all of you in this group, is 1, 2, 3. If 1, 2, 3 is in place, everything else anybody can do it. And you should know the catch in each of the step. What are those uh, important things that data scientist might go wrong with? So yeah, just giving a thought here. So this is good. So I've no questions on this. So these are the topics, right? Anything else I'm missing? Anything on computer vision? And by the way, you good with PyTorch?
We
We've
focus
worked
more on
on some applications, but not confident in using PyTorch.
For in computer vision, is it?
Yes.
Yes.
Because see, any other programming languages or tools will fail to give you the desired results for computer vision. PyTorch is the best. So I'm not sure if your computer vision module went through PyTorch all the time. What I can do is, I'm not sure if it's still available in the market. Computer vision. Okay. So this is my book, which is yet to be published. It's still open for pre-order. So once I get my copy, author's copy, I'll share it with you guys, like I promised in the day one. Okay, so you have all the computer vision projects with PyTorch, end to end, right? If you go here, you will see all the details. What all it's there. Every single thing is there in this book. I think table of content is not given here, but yes. So this is the book I think you can look for, because see, I'm not saying this is the best book. All I'm trying to say is I'm connecting all the techniques and methods and algorithms to the industry problems, which you will not find in much of the books. So from my experience, I'll try to put in that story there. How can you leverage some of the concepts and techniques to solve some of the problems? So all my books, you would see it outside in. So that's the only reason why I kind of press on having this. But if you're interested, I'll share this soft copy with you. I doubt if I have it now.
Sure, sir. That will be great.
No, I don't have it. These are all the non-shareable chapters with me. Once I get a soft copy, I'll share it with you all. Okay, so that is there. So PyTorch, I think, yeah, maybe with that book, you will not get the fundamentals of PyTorch, but yeah, you can. I'll send you some more links to get the fundamentals of PyTorch.
Akshay, in the computer vision, um, the class more focus was on TensorFlow.
Oh no,
Py-
even TensorFlow is good. Even TensorFlow is good.
However,
Even
the
TensorFlow is good.
one thing very clearly that most of the research paper are implemented in PyTorch.
Correct. Yes. And I know all the industry applications, what you build for computer vision, if you want to deploy and scale it to the production level, you have to use PyTorch.
Okay.
Okay, so this is advanced NLP book. I'll do these two on probably day 3, day 4 when time comes. So these are the things what we need to discuss on day 4. Okay. So now coming back, are we good with this or anything else? Because I need to plan my day 3 and 4 accordingly. So I'll see what could be fit and when. Anything else you want me to do here, or we are good? Are we good? No answer. What should I assume with that? Which means we are not good or we are good?
We are good.
Very good, sir.
Okay. Now, with that, shall we move on to the next topic? Or you are looking for a break? I know we skipped the break. I just realized it. So maybe can we just quickly take a break for 10 minutes and then come back? Because it's about to close as well. So
Sure.
Sure, sure, sure.
yeah, let's meet in next 10 minutes. Hello everyone, hope you're back. Yes, no? Are we waiting for someone?
Hello,
Santosh
Akshay.
is Santosh is
Yes,
back,
I
Soumya
am
is
here.
back,
Yes, sir.
Noor is back. Okay,
Srihari.
Prasad is back, Shreya is back. Okay, awesome. So with that note, let's get started. Now, can someone explain me? So we are getting into all those SWOT algorithms, right? Now, like BERT, GPT, transformers, sentence transformers, Elmo. So these are all the latest state-of-the-art algorithms under deep learning space, which are predominantly used for NLP tasks. Okay, so now before I get into all of this, right, I'll start with transformers and then go to BERT and all of it. And in between, I'll talk about attention mechanism as well. But now I want to understand from you how LSTM works. Because that's a fundamental, that's a basic. Once we know LSTM, then we can talk about bidirectional LSTM. Once you explain bidirectional LSTM, then I'll explain how transformers work. And once we know how transformers work, then we'll get deep dived into attention mechanism. And combination of all of this will give you the BERT or GPTs or Elmo or all of these algorithms. So yes, who wants to explain how LSTM works? Or if you feel that no LSTM, maybe I think RNN will take first and then we'll go to LSTM. I'm okay with that also. Yes, who wants to explain LSTM? How LSTM works? My question is very simple. I can probably help you while you're explaining if you're stuck somewhere. But without you understanding LSTM, I'm not going to move forward. Yes, nobody is talking. Or you want some time to explore about it and maybe revise it? Am I audible?
yes,
Yes,
sir.
sir,
Yes, sir. Yes.
Why there was a minute of silence?
Trying to recall actually LSTM.
But I believe it's covered, right?
it was covered.
Yes.
Yes, sir.
So then for sure I'm expecting you explain me how LSTM work. or you feel like maybe, I know it's tiring or probably not a right question to be asked at the end of the day. I'm okay with even doing it first day. I mean, day 3, the first thing. By the time, maybe you'll get some time to revise and be prepared. Because if you don't understand LSTM, then even how much ever I explain transformers, BERT or Elmo, you'll not understand.
Yeah, I think that would be better, sir. We'll get some time to refresh.
Okay, then fair enough. We'll do that. So LSTM and bidirectional LSTM is what I'm expecting you to know. I believe bidirectional LSTM is also covered.
I don't think by LSTM was covered, sir.
Yes, yeah, it's not covered.
Okay. That's okay. If you get time, explore about it. Otherwise, I'll cover it. Okay. So that's one thing. And maybe I think be prepared to maybe, I don't know how it goes, but we might have to extend either day 3 or day 4 for some more time.
Sure, sir.
Sure.
Okay. Because there are still a lot of things which are pending. And today, anyways, I'm going to leave you 10 minutes early. So I think we'll have to make it up on day 3 or day 4. Maybe we'll have to extend at least for an hour. I don't know on day 3 or 4, but I'll let you know.
Sure, sir.
Okay. But yeah, come prepared with LSTMs and explore bidirectional LSTM if you get some chance. And then we'll continue from there on day 3.
Okay.
All right then. Thank you so much, everyone.
Thank you.
Thank you.
Sir.
See you all soon.
Thank
Thanks.
you.
Thank you, sir.